So hello everyone, I'm Jel and today we are going to discuss about spheres, which is a topic from solid mensuration. So first let's go over to the meaning of sphere. Sphere is a solid bounded by a closed surface, every point of which is equidistant from a fixed point called center. So that means that this is your closed surface and each point from this surface is equidistant to a point called your center. Next is your notations. So R would be for the radius of the sphere, AT would be for the surface area of the sphere, and V would be for the volume of the sphere. So R is the radius of your sphere, area is the area outside your sphere, and V is for the volume of the sphere. For the formulas of sphere, the area of the surface of a sphere is equal to the area of 4 of its great circle. So area would be equal to 4 pi r squared. Since the area of a circle is pi r squared, and it would be multiplied to 4. Next is the volume of a sphere. It is equal to 4 over 3 pi times the cube of its radius. So this formula is actually from two cones that we have here, two cones. The height of these two cones would be equal to the height of the sphere. And the height of the sphere is actually equal to twice its radius. So for the volume of a cone, the formula would be 1/3 pi r squared h plus 1/3 pi r squared h. And that would be equal to the volume of the sphere. Now h is equal to 2r, so that would become 2/3 pi r squared 2, which is the formula of the volume of a sphere. Now first, let's discuss how we could actually get the formulas in using ratio and proportion. So first, the properties of a sphere. Sphere has its total volume as 4 over 3 pi r cubed, and for its area, or the total area, that would be 4 pi r squared, and the total height would be 2r. Now, there is actually a shorter way to derive the formula. For example, the first topic is a zone. So a zone is the portion of the surface of a sphere included between two parallel planes. Now, the formula for zone is shown in the screen as z is equals to 2 pi rh. Now, this 2 pi rh formula could be derived from the ratio of the total area of the sphere divided by the total height of the sphere would be equal to the area of the zone over the height of the zone. Now, since the total area of the sphere is 4 pi r squared and the height will be 2r, the area of the zone would be equal to 2 pi r h. This is how you get the formula of the zone using ratio and proportion. spherical segment of one base, R1 is equals to 0, T would be equal to Z plus pi multiplied by the quantity of R1 squared plus R2 squared. So the volume of a spherical segment with one base would be equal to pi h squared over 3 times the quantity of 3r minus h. And the volume of a spherical segment with two bases would be 1/6 pi h multiplied by the quantity of 3r1 squared plus 3r2 squared plus h squared. Next is the spherical sector. Spherical sector is a solid generated by rotating a sector of a circle about an axis which passes through the center of a circle but which contains no point inside the sector. So this is the figure for a spherical sector. Notations. R, or the capital R, is for the radius of the sphere, A for the total surface area of the spherical sector, V for the volume of the spherical sector, A for the radius of the larger base, B the radius of the smaller base, Z the lateral area, and H for the altitude of the spherical cap. The spherical sector formula could also be derived using ratio and proportion, but since the spherical sector is a solid, we will use the total volume of the sphere. So the total volume should be divided by the total height, which will be equal to the volume of the spherical sector divided by the height of the spherical sector. Now, the total volume of the sphere will be equal to 4 pi r cubed over 3 divided by its total height, which is 2r, and now we're going to simplify the equation. Now, the volume of the spherical sector will be equal to 2 pi r squared h over 3, since this is what's left. Next up is our sample problems. So, let's try to solve a few problems. Number 1. Find the volume of this sphere. Round off to the nearest cubic meter. We are given a radius of 8 meters. So since we know the formula of the volume to be 4 over 3 pi r cubed, we can directly substitute the given to the equation. Now substituting 8 to the equation, we will get 2,145 cubic meters. The second problem would be the surface of a hemispherical dome whose diameter is 36 feet is to be covered with a gold leaf which costs 15 cents per square feet. What must be paid for the gold leaf? Now, we need to find the cost that must be paid for the gold leaf. Given that we have a diameter of 36 feet, cost of 15 cents per square feet, let's try to solve the problem. So, this one, we will use the formula of the area of a sphere, but we should divide it by 2 since the problem states that it is a hemispherical dome. Now, let's substitute the radius, which is 18 feet that was derived from the given of 36 feet diameter. Now, our area would be 2 pi 18 feet squared. Then, let's try to solve for the cost. Let's just multiply the 15 cents per square feet to the area, then convert the value to dollars. Now, we will have an answer of $30.54 for the cost. Next problem is, what is the area of a zone of a spherical segment if the radius of the sphere is 15 meters and the height of the spherical segment is 6 meters? Now, we are about to find the area of the zone, and we are given a radius of 15 meters and a height of 6 meters. So we have a formula for the zone, which is 2 pi RH. Now let's substitute the given radius and height, which is 15 meters and 6 meters respectively. We will get an answer of 180 pi meters squared. Now for the fourth problem, let us find the volume of the spherical segment based on the given from problem number 3. So to find the volume, we are given again radius of 15 meters and a height of 6 meters. And let us just substitute the radius and height to the formula, which is pi h squared over 3 multiplied by the quantity of 3r minus h. And substituting the height of 6 meters and a radius of 15 meters, we will get a volume of 468 pi cubic meter. For the fifth problem, let us find the volume of a spherical segment, the radii of whose bases are 4 meters and 5 meters respectively, with an altitude of 6 meters. We're given an R1 of 4 meters, an R2 of 5 meters, and a height of 6 meters. Now let's solve this problem using the formula 1 over 6 pi times height multiplied by the quantity of 3r1 squared plus 3r2 squared plus h squared. Substituting the height Now for the sixth problem, let us find the volume of a sector of a sphere given the radius is 10 meters and the height of the cap is 9 meters. So we are given a radius of 10 and a height of 9 meters. Let's try to solve the problem. For the formula for this problem, we have 2/3 pi r squared times the height. Substituting r, which is 10, and a height of 9, we will get 600 pi cubic meter for the volume. Now that was our last problem. Thank you so much for listening to our tutorial. I hope you learned a lot, and see you next time.